Okay, so if we're talking some more algebraic limits, just want to go through a few situations you might encounter. Of course, I can't show them all to you. You have to be problem solvers, but there are some problems where you might run into something like this. Eight to the 2t minus 1 and 8 to the t minus 1. I made this up, so hopefully it works out.
If it does, I will laugh at you.
We're all going to laugh at you.
Oh.
Okay.
No, no.
So first attempt here, what do we do?
Plug
Plug and chug. What do you get?
0.
Yeah, okay. Thankfully, we get an indeterminate form, right? Okay. Question is, can I algebraically manipulate that?
Yes. Wait, no,
Okay.
you cannot.
The key here is knowing how to take care of this right here.
Yeah, that's the problem.
Do you remember how to add exponents?
No. Oh.
Yes, I went over this with you yesterday, so do tell.
So it's 8t plus 8t, well, times.
Okay, so 2t is t plus t, right?
Yeah.
There's two of them?
That makes it 8t.
Remember that property?
Yeah. You made this problem up and you gave it a crap variable.
Yeah.
So do you remember this exponent property? If they're two same bases multiplied, you add the variables and combine. Right? How can I apply that to this problem?
So you have 8 times 8t minus cancel one out.
8t
Every other op.
and 8t.
Ah, crap. Plus or minus 1.
It's the same, it's a difference of two squares still. It's just funny. Something we don't see very often.
It just looks weird.
So we have these two, and we multiply first times first, we get 8 to the 2t. The plus and minus cancel the o and the I, and the last minus 1. So now we can do this, right?
Yeah.
And answer. So, again, this is a situation I wanted to show you because you might run into it. You will run into it.
Question 15.
And I only put that in here today because somebody asked me to. So if you come get help, it pays dividends.
Hold up, I'm gonna get that ready.
It's not time to sit down.
That's what I thought it was like 8 t like down next to it, not.
Okay.
Why?
That one.
Ooh, fun.
Evil.
That one.
It's not evil, especially since he's telling us how to do this. Ah, you changed it too. That's something.
Okay. So this is a little different, but it's still an algebraic limit. Plug and chug. If I put 1 in the bottom, in the denominator, 1 over 0, what are we approaching though?
As x approaches what?
Okay, if the denominator continues to get closer and closer to 0, what happens to this whole number?
It's smaller.
Denominator gets smaller,
No.
number gets
Bigger.
bigger. What's the biggest thing we could think of?
Infinity. Beautiful.
Right? Minus, and then this would also be infinity as well. Right, so small bottom makes a big, big number. This is also an indeterminate form. Okay, so we can algebraically manipulate this equation to suit our wants and our needs. Any ideas?
Change the 2 over x squared minus 1 to x plus 1 and x minus 1.
Ooh.
And then you can
Okay.
times the first one by x plus 1 to make the denominators the same.
Yeah, I was about to say.
Wait, we're making this work. Huh? I don't think it's making this
This is what you just said, in effect.
And then multiply the first
So-
one by x plus 1.
Factoring this bottom here shows us that we have x minus 1's matching. All we need to do is multiply by x plus 1. Remember your rational functions don't have a seizure. Now the denominators match, and we can combine. Okay?
So that's 2x plus 1.
It's an algebraic solution method, right?
2 times x.
Please do not forget to keep this here. A lot of you are dropping it. Okay? Because if you write equals and this is not here, it's not a correct statement.
I'm.
Okay, when I'm approaching 1,
Yes.
right, so let's say I get 0.99 in here. 0.99 minus 1 is 0.01. 1 over 0.01 is 100. But if I put 0.999 in, the bottom is 0.001 and I get 1,000.
Okay, so
10,000, 100, where's it going?
yeah.
So really small numbers on the denominator make an infinite limit. Huh?
So at 3.
So we don't have, 1 is undefined, so we have to use like 0.99 numeric analysis. You do, but it gets 1 over 0, that's undefined. Then we have to go to some other technique. Not necessarily. Be careful with that statement, but it's very common. Okay, so here we're okay getting common denominators. Do not drop your limb as x approaches 1. What does the top become? X plus 1 minus 2 is
Negative x minus 1.
x minus 1, and the bottom is x minus 1, x plus 1, right? And you can probably see what we do now, right?
Cross.
1 over 2. Got it?
No, let me go.
Once you cross or factor and eliminate, substitute 1 in, plug and chug, good to go. Okay? So all that pre-calculus algebra,
Without being put to use.
we're using it. We're good?
Yes, sir.
We're gonna use quadratic equation, aren't we?
Feelings can be deceiving.